everybody. Good afternoon. Welcome. Thank you for joining us today. My name is Chris Lacey, and I'm a technical marketing manager at Usalco and the moderator for the panel today. We have enabled the Q&A section in Teams for you to send in any questions, and we'd like this to be a conversation. Please send any questions that you have in through the Q&A, and we'll pivot to those as fast as we can. There will be a handful of times throughout this discussion and where we're going to ask you for input and ask you if you have anything to add or if you have any questions pertaining. And those are great times also to jump in. And then lastly, at the very end too, we'll have some more time. So, but again, feel free to add questions and comments anytime. This is meant to be a discussion. So a couple of poll questions that we wanted to start us off on before we begin. So let me go ahead and get those going. Let's do, here we are. So the first one is, do you or your team conduct physical jar testing every week to support operations? Yes or no? I'll give everybody a little bit of time to answer that one before I pop up the other one. We just have two questions. We wanted to kind of gather some information about the crowd. All right, looks like it's fairly even split so far. 55% yes, 45% no. Let's see. This is the polling's kind of new for us on Teams, so oh, there we go. We got more responses come in. I'll give it another few seconds, and we'll pop on with the other one. So it looks like the majority do jar test week to week. So let's go ahead and add our next poll question. And this one is, what type of water do you or your team typically focus on treating?
I don't see it, Chris. Yeah, that comes. Yeah.
It takes, yeah, this one takes a little while.
Yeah.
We'll give you guys a little while to respond to that. So we have drinking water, municipal wastewater, and just any type of industrial process water. It's like we have a lot of drinking water folks here. So the vast majority, and then it's pretty evenly split on the other side. All right. Well, great. So that's good information there. So I'll go ahead and close these polls out so they're not hanging around. Thank you all for participating in that. So let's go ahead and jump into introducing our panel today. So Chris Miller is Vice President of Digital Innovation at Usalco. He leads initiatives that help customers leverage technology, data, and digital tools to improve operational performance. Chris has dedicated his career to developing innovative solutions for water and wastewater treatment with technologies and methodologies adopted by utilities and industrial customers across the industry. Chris lives near Pittsburgh, PA with his family. And then we also have Brad Spangler here today. He's our Vice President of Sales at Usalco. He has over 25 years of industry experience, including water, wastewater, pulp and paper, and other industrial applications. He currently leads the commercial efforts, which include a group of highly technical sales personnel. This group prides themselves on solving customer problems and addressing industry challenges. Brad resides in the Baton Rouge, Louisiana area with his family. All right, so let's go ahead and dive in real quick. So let's get started with why jar testing still matters. This first question is for Brad. Brad, for anyone who hasn't run a jar test recently, remind us why it's still the gold standard and what an operator can learn from the bench that's genuinely hard to get anywhere else.
Thank you, Chris. It sounds like a lot of people on the call are actively jar testing. But again, I think what we see is people are jar testing still today to get an idea of where to set the coagulant dose. You see many municipalities that will run a curve with their current coagulant, a variety of doses starting from low to high, and their influent water changes, and so whether they're coming in for the morning and trying to determine where to set the coagulant for the day, a good jar test and a curve will help them do that. Other municipalities have the luxury of, sometimes they are able to pull water upstream of their municipality. So let's say you've got a big rain event and there's some high turbidity water coming your way. I've seen some municipalities that are able to test water that they know is going to hit their plant in 1 to 2 days. That's a luxury. Not everyone has that, but there's no surprises there, right? They can run a quick curve, and instead of upsetting the plant, they can run this jar test and get ahead of any upset conditions. So I guess in summary, what we see is people are doing that to set the coagulant dose. As you know, you have to have the jar test protocol correct to get any meaningful data out of it. You got to have your mix energy correct. You got to have your mixing time correct. So long answer, but I think to set the coagulant dose is probably what we still see as the primary reason.
Awesome. Thank you, sir. And then I have a question for Chris. You've spent your career in water treatment research. What makes the physical jar test such a durable, trusted tool? And what got you interested in building on top of it with machine learning and multi-objective optimization?
Yeah, thanks, Chris. Great to be here and great to see so many people today on the call. So looking forward to some of the questions and input as we get rolling. So prior to joining Usalco, I was a civil engineering faculty member at the University of Akron, interested in drinking water treatment research. Noticed a few things along the way. So kind of while the physical jar test was the gold standard for those that were looking at how do you calibrate and get some additional sort of data analytics information from that, there was a paper published in 1999 by Mark Edwards from Virginia Tech. You may have heard his name before because he's also an expert in lead and was involved with the Flint, Michigan testing. But Mark Edwards published a paper about how do you actually calibrate for different coagulants. His paper looked at alum and ferric, kind of your core commodity products. And so looked at that. There was then a paper published about 5 years later that brought in, we all know that the nature of the TOC can impact treatment performance. So Edwards kind of approached looking at how do we bring a coagulant piece into this? And then this paper by Castle and some others 5 years later was how do you bring in, the TOC and the nature of the TOC into that? And so nothing had changed then since like 2004 looking at that. And as I started to consider additional chemicals impact, so pre-oxidants, powdered activated carbon for TOC removal, how are we going to actually not only kind of test the coagulant and traditional TOC and turbidity removal, but how can we also bring in the other things that are impacting both the turbidity performance as well as the TOC performance? So, how could we actually then maybe bring in some simulation tools and saw a gap there?
Awesome. Thank you, sir. So let's discuss the best practices now, insights and use for physical jar testing. And we'll start with Brad. Brad, across the plants you've worked with, how do operators actually end up using physical jar testing? What are the best practices, insights, and use cases?
Well, it kind of, like I mentioned a few minutes ago, how they use it is a lot to set the dose, right? So, we'll run the curve, or plants will run the curve to help set their coagulant dose for the day and for the incoming raw water parameters. Some of the best practices, we always like to dose with micropipettes. As you know, that it helps improve accuracy, and it also feeds the product neat as opposed to stock solutions. What we found is that the coagulant will begin to work right away. So if you use stock solutions or dilute or made down coagulant solutions, you can lose some activity in the coagulant. So again, we like to feed neat. We like to use micropipette. Some of the things they're looking for, obviously, it's visual inspection of the jars. You're looking for flock size, flock speed. How quickly does it react? How quickly does it settle? Some plants have short flash mix, so they don't have a lot of time. They need a coagulant to work quickly, right? Flock quickly and settle quickly. Others have plenty of time, but those are some of the things I think best practice wise. We always recommend micropipettes. For accuracy, we want to be extremely accurate in our jar test protocol, along with best practices. I believe some of the operators, in addition to final TOC removal, right? We'll test the jars for how much TOC we're removing on that day, final settled turbidity numbers, but we don't just look at the final turbidity. We like to sometimes get a curve so to determine how quickly it's settling as well. So those are some that come to mind.
Awesome. Yeah, I was thinking when you were saying that, I've been to some large utilities that are really lucky and they have a TOC analyzer in their lab. And so they'll run a test every morning and then run TOCs on their jars and really optimize their dose for TOC removal, which is not common. Most people don't have that luxury, but that's a great use case. For the audience, I want to kick this back to you guys. Any other best practices for use cases that you would like to add, or any questions about these? I'll give it a little while in the Q&A section. Feel free to chime in. It looks like we might. Oh, here we go. We have a question. So do you also recommend using chemical addition discs to optimize timing between jars?
Absolutely, Chris. As you know, we use them all the time. We love the disc. I've seen rulers set up where you can inject them all at once, but our team, I believe almost all of our team are using the disc. We input the coagulant from a micropipette right onto the disc. So yes, we like it. Anything you would add to that, Chris?
Yeah, so if your injection points are varying, right? If you have your coagulant at the very front before like, let's say ahead of the first flash mix, and then your polydamac or polyamines being injected maybe just after the first flash mix, that's a great reason to use those discs at different points in the procedure, right? So you'll inject and then you'll wait, your 30 seconds to a minute and a half or whatever it is, and then you'll inject the polymer. So absolutely, we recommend that. It works very well. All right. Any others? Any questions? We'll keep on trucking along here. All right. So let's discuss physical jar testing challenges. And so this one will be for Chris. What are some of the challenges with conducting physical jar tests and their adoption by water utilities?
Yeah, so some of the obvious ones that come to mind is, have team that is busy and, staff, lots of responsibilities. So sometimes finding a dedicated person to do that. We're talking about, even though you can train to this, it's not always simple and easy to, be precise with the pipettes and the dose calculations, and especially if those things are changing. So really getting somebody dedicated to do that can be a challenge. Sometimes if you have a more complicated component as part of your treatment process, like ozone, or you can't exactly replicate treatment. So sometimes you can find ways around that, or accept certain ways that you handle that. So those are probably a few of the ones that come most to mind, Chris.
All right. Thank you, sir. And then Brad, anything to add to that?
No, I think I would probably piggyback off of Chris's answer there. We hear the same thing, staff challenges. So some of the municipalities that we work with, they mentioned some of the same thing. We maybe don't have someone on staff to do it every day, or we don't have time to do it every day. And that's why I believe this virtual jar can be very helpful. In fact, we've even seen it with our commercial team. As you know, from a commercial standpoint, we like to run jar tests over a variety of incoming water parameters. We may jar test for 6 months to a year because we want to see cold water, we want to see warm water, we want to see high incoming turbidity or low. And that's what I think is great about what Chris is doing here on the virtual jars. You know, maybe we can simulate some of these things so that and shorten the time, right? We don't have to. Sometimes we'll tell the municipality, hey, call me when you experience a high turbidity event. And with the virtual jar, sometimes you don't have to wait on that. So we've seen it on our commercial side as well.
Awesome. Thanks, sir. And then for the audience, any challenges that you guys are aware, you know, that you've had that we haven't already talked about, feel free to pop those in the chat and I'll bring them up as they come in. So let's go ahead and introduce the virtual jar because it's been on the screen now, but we haven't really talked specifically about what it is for those who don't know already. So for Chris, what is a virtual jar?
Yeah, I'm going to go ahead and move back to this slide, Chris, to help kind of inform that. So best way we like to explain it is think of it as a flight simulator. That may show my age a little bit, but I remember the first Microsoft flight simulator that you could do back in the day. But as Brad alluded to, is the ability to run a bunch of different scenarios that are still, you know, based in what's going on currently at the plant. But it will. What is it actually simulating? Is it simulating the different coagulant dose ranges, the different pHs that happen with that, and so it's handling the heavy lift on the calculations and doing a lot of what we know intuitively happens, but it can run those calcs and take care of that and bring into it both how the physical jar performed, the treatability of the organics that you're experiencing. So there's this connection. We can continue to elaborate on it today, but between this physical jar test, as the little graphic shows, and then there's an intermediate step that is some machine learning parameter extraction, as I was alluding to those papers that were published about 25 years ago. And then that information we can put into a simulation tool that can run many different kinds of scenarios and evaluate those for the water operator before they make a decision.
Awesome. And would you like to be on this slide now, Chris, or we want to stay back for? So let's talk about this. So let's get concrete about something a lot of people don't realize. How does a physical jar test actually inform the virtual jar? I understand there's a machine learning step that extracts chemistry parameters directly from the bench data. Walk us through that. Yeah.
So we're actually applying the method that was published in 2004. They used Microsoft Excel's solver function, which is where you have data, you have a dose response curve, like Brad said, and you can extract these 4 parameters. So that's an error minimization, machine learning type technique. We're doing it. We've made some improvements to that. We're actually working with a couple of our customers that we're going to look to probably publish some of that later this year. But 2 of the parameters are more or less related to the coagulant, kind of specific to the coagulant that you're using, and 2 of the parameters are specific to the treatability of that TOC. So if you have, again, people think about SUVA, higher SUVA is easier to treat, or higher TOCs, you could remove more TOC. These are actually parameters that are really specific to how much of that TOC can you actually remove via your coagulation process. So just the 5 steps kind of on here about how it informs. So again, we said physical jar test, get some data. You really do need either TOC or UV254. UV254 is a good surrogate, much easier. You can get a benchtop unit. Like you said, Chris, not many people have, or many utilities have a TOC analyzer on site, so we've found a way to make use of if you've got a UV254 on that step 2, but we take that data, do that machine learning parameter extraction, and then that allows us to inform and build out really your digital twin or your treatment, the virtual jar that can run these simulations of the treatment plant, look at a bunch of different scenarios and then help inform so the operator can make a decision.
Awesome. And then, so for Chris, so once those parameters are obtained, how does virtual jar actually forecast the turbidity in the TOC? Not a dose response curve or an expected like TOC value, but a blend of coagulation mechanisms and profile of the organic carbon.
Yeah. So there's a simulation component to this. So the way we set up virtual jar is that, let's say that you're currently dosing the coagulant a dose of 30 milligrams per liter. You generally have a range that you're willing to move that dose in any one step, right? Whether it's 2 parts, 5 parts, what is that dose range? So that helps put in the guardrails of how much do you want to examine. So for my example, if you're at 30 and you're willing to go plus or minus 5 milligrams or parts in one move, we could look at 25 to 35 plus or minus 5 parts, and we can run all the dose. We can run it in increments and run the dosages. And then when we are calculating that, we're calculating the pH changes, which helps inform, people know about enhanced coagulation, right? Suppress the pH, you get better removal. Well, the reason you get better removal in simple terms is you're generally adding more coagulant. So of course you would expect performance to go up, but it really is that pH that moves, that how a fraction of that TOC will actually absorb. And so we're doing that calculation inside of that as well, not just looking at, hey, this is enhanced coagulation, suppressing the pH, because we know you can get good organics removal by minor pH changes, right? Using higher basicity or using blended products. It's not always just about suppressing the pH to get better removal. So chemistry calculations, absorption calculations of the TOC, and incorporating the nature of that TOC, all those things wrapped into how, running those simulations and then providing them in an easy way for the operator to digest so they can see those trade-offs.
Got it. So thank you, sir. Looks like we had a couple questions come in. They're both, looks like both for Brad probably. So let's start with the first one. How about optimizing coagulant dosing using a combination of jar testing and streaming current monitor outputs? So have you come across that, Brad?
Yeah, absolutely. I mean, I think Chris was going to touch on it maybe later in the deck where he talks about charge neutralization at SCDs. But yes, we've seen it also where you're running the jars to take at X amount. This is what dose you're going to destabilize the particles and actually cause it to settle out. So yes, we've seen where you can use both. Chris Miller, anything you would add there on the SCD as it relates to the virtual jar?
Yeah, I think it ties into one, like you said, we were going to talk about next, is that one of the things that we recently added to the virtual jar is a net zeta potential forecast. So you so let's say somebody does not have, so to the person who asked this question, somebody that does not have zeta or streaming current, we are actually forecasting that net zeta off of, again, the turbidity has a negative charge. The TOC has a negative charge associated with the coagulant. That's the positive contribution. We would do that calculation and forecast the net zeta so that, again, if they don't have it, but if you do have streaming current or zeta potential measurements, we can actually then tune the virtual jar to what you're seeing as part of that and help assess, again, the charge neutralization part and have that be part of the how it's ultimately impacting turbidity removal as well as TOC.
Thank you, sir. It looks like we have another one, and this is more of a response to the challenge question from earlier, I believe. Response time can be a big challenge for people. The time delay in between the jar test results and then the process response to the chemical change out in the process, right? And so that's a big challenge that people come across a lot of times when they're jar testing. So that's
Well,
a
Chris,
really
I
good one.
think
Thank you.
that's one of the things, that's where having virtual jar comes into play. So again, we're talking today about if you run a physical jar and then you go ahead and, but if we're working with a client of ours has an active flow system, right? That's turning over every 20, 30 minutes, right? You don't, so they're actually they're using virtual jars. They see those changes because you can run a simulation in about a minute. You can actually look and try and, as that raw quality is changing and you want to actually make the change and go with it, you can do that. So, or if you also know you have that delay, you have long sedimentation, may take several hours, how do you want to kind of maybe, if somebody's at a river source or getting a rain event, there are ways to kind of blend using both of these tools to try and close some of that time gap. Yeah.
Awesome. Looks like we had another one just come in for Brad. What effect, if any, do you find that pH has on performance on the bench when compared to the actual process?
Well, we try to match. I'm trying to think in the jar test, we're going to try to match what we're doing in the plant, right? So we're hoping it's the same, right? We're hoping that the incoming water is the same as what we would see in the plant. So in any jar test, whether it's mixed time, mixed energy, pH of the incoming water, we're going to try to match as close as possible to the plant so that we can get meaningful results.
Yeah, I'll add one of the hardest things for me when I started off in jar testing was matching a ferric sulfate with lime plant in the jar, because they're feeding this lime slurry, and getting a lime slurry into the jar at the right concentration takes some skill, and you have to be very careful, and it takes a while to get good at it. So that is not a pleasant thing to try to figure out, that's for sure. It's very difficult, but yeah, that's the goal. Is we want to match the plant in the jar. So we have two new outputs, and I kind of jumped to this screen because you were talking about zeta potential, Chris.
Yeah.
And so you talked about that, but we also have this new organics treatment index. What hole or gap are you trying to address with these two new outputs?
Yeah, so I think we just talked about relative to turbidity removal and thinking about charge neutralization as the key, one of the key mechanisms that's kind of, definitely treatment 101. So I've got this slide up here. We talked about charge neutralization. There's always also, whatever the sedimentation, particle settling, again, it can be totally different whether you have just whether you have plate settlers, whether you have DAF, whether you get them. So probably should have put their sedimentation. How do the particles actually get removed out of the system is part of what's included in the turbidity modeling. But on the TOC, Chris, as you mentioned, this sorbable organics and non-sorbable organics, those are those two core fractions that have to be addressed and looked at. And so we went ahead and introduced, I talked again about net zeta, but on this organics treatment index, this is the percentage of that TOC that you can actually remove via your coagulation process. If you are also adding powdered activated carbon, we can include that in it as well. So this is showing a number of like 68%. What that 68% represents is not 68% TOC removal, that's 68% of the fraction that you can actually remove with your coagulation treatment process. So it's, we think it's a little more insightful about, the efficiency of what you're actually doing at the moment, the treatability of that water, rather than strictly just looking at, how much TOC am I removing? Because what you are trying to really assess is how efficient is your coagulation, treatment process for what it can actually remove. So I see a hand up, Chris, if we want to take the question or.
Yeah, I just unmuted Eugene. Eugene, it looks like
Okay.
you have a question. Go for it. Hopefully this works.
Yeah, can't.
Eugene, you there? You should be able to talk. And if you can't, feel free to drop your question in the Q&A too. There we go. We draw from Lake Erie and our water changes continuously. Looks like
Yeah,
he's
so
still
we
Yeah.
actually have we have several clients that draw from Lake Erie and have been using virtual jar for several years, even also during some of those dead zone anoxic events that have happened that bring in lots of manganese. So today we talked primarily about turbidity and TOC removal, but we've actually added to their virtual jar manganese removal. I mean, just it only happens, in rare periods during the year, but then they can adjust the oxidant as well. So, yeah, our river sources are, again, active flow, things that are turned over. So I think that where the bridge from the physical jar test is that those the the nature of the TOC that is being treated, and we know again Lake Erie, high quality water generally, but that treatability does change quite a bit as well. So getting those historical values that you can only get from a physical jar test, those help build out some record that help involve kind of almost the guardrails or what's possible for what's the treatability of that water. So um, I don't know if Eugene that helped address that or not, but so we are going to talk about a workflow, kind of a workflow that involves a physical jar test with a virtual, but you can run a virtual jar test as needed on demand. So if, something changed over the course of several hours, we have, again, customers that will just run the virtual jar, and then if they want to supplement it with the physical jar test, there's many different ways to bring these two together. So.
awesome. Thank you, Chris. It looks like we have another question that came from Andrew. So when evaluating different coagulants, how do you determine whether the new product has a higher or lower effective charge? Any standard methods to characterize charge? That's for either of you who want to take it.
Chris, I mean, you talked a little bit earlier about charge neutralization. Anything you want to add on the virtual jar with different coagulant products?
Yeah. So I mean, Usalco has quite a portfolio that has, different basicity, provides different charge, right, for different, even for dosages, right? Not all aluminum is the same, right? So we do bring that into the virtual jar component, as well as obviously if you're testing a different product in the physical jar. Again, our water treatment specialists know how those are going to behave and whether kind of how you're balancing the different, basically the species of the aluminum to address, particle removal or turbidity removal versus TOC. So sometimes we want to try and match up, is the customer primarily focused on, let's make it simple, that mostly it's about turbidity removal, or it's 50-50, or is, in some cases, could be weighted towards one or the other. And that's where, we'll tend to customize or guide that product selection to meet where kind of their weighting is, where their focus is, if you want to call it the bigger challenge, or they have to treat things equally. So,
Cool. Thanks, sir. So let's discuss an ongoing project. This is for Chris. One of our utility partners runs a physical jar test on a weekly basis, and there's been a combined physical to virtual jar workflow running there for more than 3 years. Walk us through what that partnership actually looks like week to week.
Yeah, so we've been working with them now for about 3 years. It's a river source. We're in the habit of running every Monday, running a physical jar test. So they run a physical jar test on Monday. Those results would come in within a couple hours. The operations team would meet, and in a way, it would help set the dosage for the week. Now, obviously, if there was a rain event or if there was something that happened during the course of the week, they could run another physical jar test. But that was kind of their workflow. So when we brought virtual jar to them 3 years ago, The only change to the workflow was that Monday afternoon, when they would be looking at that dose response curve, they would also run virtual jar, and it would allow them to examine some other dosages. They could look at now this organics treatment index, like where are they at efficiency wise. And where that comes into play is that I know it's not the largest graph, but this graph in the left middle of the plot here, or the chart, is a TOC removal for 4 different dates over the course of the last over the year. They're not in chronological order. The main point of this was that even though their dosage range remains reasonably within a plus or minus 5 parts, they would see these big swings in TOC removal. Again, anybody that's looked at a lot of organics removal data sees that these things can change even though your dosage is, relatively consistent. So this didn't have anything to do with, the coagulant or what they were doing. It just simply had to do with that water was harder to treat when those removals dropped from 60% TOC removal to 21% removal. So what that allowed, in combination with the virtual jar, was that they looked at that organics treatment index. They knew they were actually getting a reasonable amount of removal of what they were supposed to. There just wasn't much there that they could remove. So it provided that additional insight to not just keep cranking up the dose, to try and hit just an arbitrary TOC removal target. So they were meeting their required removals, but they like to go above and beyond because it helps them manage their disinfection residuals, helps manage their DBP levels. So they tend to shoot for even higher removals. So again, been now doing this for about 3 years. That is the week to week flow, but they can also run virtual jar. They get a rain event, they get a river event. They either will initiate another physical jar and then inform the virtual jar. They'll just run a virtual jar test. So, and again, they've been very interested in how it supports the disinfection and the DBP parts of their water quality goals as well.
All right, thanks, sir. So I have a question for Brad. A lot of your work is matching a plant's treatment needs to the right coagulant. How has the combination of a physical jar and a virtual jar test combination helped that effort?
Yeah, you're exactly right, Chris. As you know, our team, we do that quite a bit, right? We're always searching for the right coagulant. We've observed some municipalities may have a coagulant in play, but we're always asking ourselves, can we do it a little bit better? Is it the right coagulant? We're auditing ourselves, even accounts that we're feeding. And if we can improve it, we're always looking to improve it, right? So running side-by-side jar, and I can think of a couple of instances here recently where virtual jar allowed us to run the incumbent coagulant, if you will, side-by-side with a few different simulations, different products, right, to help predict what the outcome will be if and when you go to full-scale trial into a plant. And it was very helpful, right? It helped us simulate what was going to happen in the plant, and it was very accurate. And then it allowed that plant after the fact it continued to aid in the decision-making process. So I think the two together is very helpful. As we're evaluating different products, it helps in the decision-making process and basically tells you what's going to happen in the plant before you do it. And so there are no surprises. That's a very helpful tool.
Awesome. And again, the only reason we can do that, right, Brad, is because we know how the different blends and how we're trying to get that right basicity, metal content, all the above, matched up with their objectives. So the ability to bring that into and in a way run our own simulations to help inform that, wouldn't be possible unless it was one of the questions is how much of this is like just observed data, empirical data. It's not that at all. It really is because we know the chemistry, and we can bring those things into that evaluation and that analysis.
All right, let's change the subject just slightly. So it's not a big change, but we're going to move away from the case study now. So physical jar test and virtual jar test adoption. So for Brad, what's the most common pushback you get from a water utility on physical jar testing or the virtual jar?
Well, I can speak on the physical jar test. The biggest pushback I think that we hear, some municipalities will say, or some customers will say, that my jar test doesn't give me meaningful data, right? What I get in the jars doesn't match the plant, and therefore I can't use it, right? And I talked about jar test protocol earlier. If we're using the standard out of the box jar test protocol, flash mix 30 seconds plus a medium plus a slow mix and a 30-minute settle, it's probably not going to match the plant, right? So as you know, we spend a lot of time trying to make sure that our jar test protocol is correct. We spend a lot of time out in the plant measuring basins, RPMs of mixers, so that we can get meaningful data out of the jar test. So I think that's probably the number one response I hear, is that if there is any pushback on the jar test, is that it doesn't match my plant.
Yeah. Scott Williams just put something in the Q&A. I'll read it to everybody because it's pretty good. Just a quick comment regarding how many operators conduct jar testing but are frustrated that it does not match the actual plant performance. There can be many reasons why, but working to get an accurate similitude is important. A vast majority of the time, the variations come from energy differences in the jar versus the plant, and changing the settling times in the jar test to accurately represent the plant overflow rates. I also, when making a coagulant change in the plant, grab a sample from the rapid mix and put it on a jar tester at slow mix speed, and this will shorten the time to find the right dosage in the plant. If the intermediate rapid mix sample is not producing a good flock, then most likely it will need further change. And so that's a great trick to use. Running, like when we run trials, we'll do that because it saves a lot of time at the beginning. But thank you, Scott. That's great. And thank you, Brad. Chris, so if a utility is skeptical but curious, what's the lowest risk way to start? And where do you see this partnership between the physical and the virtual heading in the next few years?
Well, the easiest thing is to contact Brad and one of our water treatment specialists and start a conversation, right? So that's the easiest way. But in all seriousness, one of the things that is often a limitation is a lack of organics removal information in the plant itself. So if it's like the monthly, required TOC removal is the only data that's available. So we will, I mentioned earlier, you can get a decent benchtop UV 254 unit. Sometimes people don't even realize that they've got the Hawk. Depending on what model you have, you may already possess that capability. But we've got a simple SOP. Want to make sure the samples are filtered, because if you have particles in the sample, it will interfere with the UV 254 measurements. We have a nice SOP to help kind of get that in place. And so because it's a large part of the coagulant demand, the coagulant performance, even when you're looking at particles. So that's the, if we're going to really go into this path and begin balancing the coagulant for TOC and turbidity removal, that's kind of the barrier to entry to kind of get that in place and help implement that and show how that can actually become something that, like, 2 minutes a day, and you can really assess the organics removal performance of your plant. So from a technical adoption using digital tool, there's a reason it's called virtual jar, because again, we're not going to show the software interface today, but it's built like a jar test, so an operator can actually put in chemical combination that they're thinking about and what they're thinking about making a change. So this has really been informed. We've been at this now for about 8 years, been informed by our customers to make it as easy and aligned with how they're thinking about making these changes, not some crazy simulation tool. It actually is built to kind of respond and help inform things, much like a physical jar test does. So
awesome. We had a question come in for you, Chris. Will the
Yeah.
virtual jar, this is probably from like one of our coagulant distributors who resell our products. Will the virtual jar test be available to be publicly available for your vendors, or will it only be available internally to Usalco?
Yeah, so so Faunus Blue was the company that merged with Usalco. We've now been on this journey for about 13 months. So I think we have a pretty good process down for our water treatment specialists and team. And I think one of the things we're excited about is talking about how do we introduce it to our distributors and that. So I think that's would love to have you follow up with us. And if you have some ideas and thoughts on that, keep in mind that each virtual jar is a custom build for a treatment plant. So because they may have potassium permanganate or sodium permanganate or free chlorine as an oxidant, what's your coagulant? So part of this is figuring out how, how do we actually bring that to support specific clients, et cetera. And I think, Brad may have some thoughts on that. But like I said, we're really, trying to think about that in the next few months and how we can make that available and help support our distributors on that front. So
Awesome.
stay tuned. Stay tuned
Awesome.
and follow up with us. And again, let us know your thoughts on that.
And we had two more come in. Jose is asking, we've seen a few new potable water plants using DAF technology, and also did a project in Asheville to get emergency treatment in place that use DAF. Jar testing on DAF is hit or miss unless you have specialized equipment. Is there a capability in the virtual jar to simulate the DAF process yet?
Yes. So again, we didn't go knee deep in this or get really into the weeds, but one of the advantages, if you will, or one of the gaps the virtual jar can close is we will use the actual measured performance to help tune or inform. So while we use physical jar to inform what's possible, under the conditions you tested, virtual jar will actually use in-plant performance data. So it's an advantage when you have ozone, or in the case like here, like DAF, and you're looking at what is the performance of the DAF units. Will actually, one of the inputs will be, what's actually happening now. And so it can tune to, some of those empirical external factors that are outside of the chemistry realm and that are impacting, again, we're not modeling bubble size and all this kind of stuff. We're actually, we'll just be like, hey, here's how those units are performing. We can bring that in along with that chemistry part and get good simulation or good forecast to what, if the operator made a change, what should happen. It allows us to make that forecast with confidence using the real plant performance as well as the chemistry of whatever coagulant you're using.
Sounds good. So we have 3 more questions so far. All tests on raw water will help with what dosage to start on jar tests, such as turbidity, color, and alkalinity. So I guess generally speaking, when you're beginning with brand new raw water, what dosage would you start with? And to target turbidity, color, and alkalinity removal, or not alkalinity removal, but turbidity and color removal, probably.
I
Brad,
think like
or Chris,
I was just going to say, I think like what Brad said is that, oftentimes we hear, hey, come in the summertime, come in the winter. Part of that's to capture the temperature, but it also is to capture different water quality conditions, right? Whether it's a TOC level or even you'll see alkalinity shift, right? Lake reservoir turnover, these, different things. So I think that, again, what Brad alluded to is that regardless of when we go in and test, once we get an idea of, I think it's more important to see, like, are we matching the right coagulant with probably what some of those goals are. Once we get one of those physical jar tests, you could actually give us, hey, you could give us some historical data and we could actually run different historical dates. So when I'm showing the Pittsburgh, I meant, sorry, who it was here. But this large utilities results here, they wanted us to actually examine, these were 4 different scenarios that had different SUVAs, had different, water quality conditions, pH. And so you can actually go back and run some of that and see, like, depending on what your targets were for it, you know, maybe meet required TOC removal, et cetera, and see how much that would change things. So hopefully that connected that bridge that, but we still want to know how the coagulant behaves on at least, you know, one physical jar test helps us anchor, and then we can bring in some of the other what ifs simulation on historical dates. So.
Got it. And just for the audience here, we're at the point now for Q&A. So feel free to fire away on that. We're going to keep going. So we have another question from Rosalind. She says, wastewater utility here. Can this system be used with a chemically enhanced high rate primary treatment system? We use jar tests to adjust our dosing to treat wet weather flow to a TSS standard.
Yes. That'd be the short answer. So again, where I go with yes is that what I was mentioning a few minutes ago about using the actual plant performance data. So you've got, and again, whether you're using a surrogate for TSS or however you're getting, you know, whether it's turbidity, you know, however you're capturing the actual performance removal live. So you can make, again, I think this gets to that heart of how do you make decisions quick when things are moving quickly, like during a wet weather event. So hopefully answered that, you know. So again, where we're going to lean on the actual performance. And then I was saying about being able to make a change with confidence. It will tune to that real data in the real plan in the moment. And then do you need to, you know, again, I like to say, you know, which direction you would probably adjust the coagulant. Like if you're not getting the solids removal during that high weather event, you're going to turn it up. But the question is how much. I think that where the virtual jar comes in place, it help you quickly assess, you know, is it 10 parts, 20 parts? What is it that we need to go up to get to the performance in real time? Yeah. But very familiar with that. Taught at the University of Akron. Akron has, they haven't had to use it much yet, but they have that high rate treatment in place as well during their real large storm events.
Awesome. Our next one, what is the difference between the AI plant simulation and the virtual jar?
What was that again, Chris? An AI? Was that it?
Yeah, what is the difference between an AI plant simulation and the virtual jar?
So like an artificial intelligence, right? The AI, is that what it's on there?
Yes. Yes,
Again, my colleagues have heard this story many times, but 2015 actually published a paper using neural networks where you take just plant performance data, fit a neural network to it, you know, so whether it's like AI or, you know, take historical data and do that, and you know, published the paper. It was the first like kind of V1 that we were doing with virtual jar, and it started to hallucinate. So while we're familiar with how large language models, ChatGPT, can hallucinate or make things up, our virtual jar would say that something was mathematically possible. So we went back to the drawing board and made sure that the foundational parts are chemistry. So my answer is that, and again, our competitors or there are others out there that may just take that machine learning, artificial intelligence approach, and it's going to hallucinate, much like, you know, while we can trust it, you know, 80% of the time or something, so we need something that you can trust 100% of the time is going to be, you know, guide you the right direction. And so foundationally it has to have chemistry at its core. Otherwise you will have the hallucinations piece. So that's the primary difference. Yes, ours is based on fundamentals and chemistry, and then we do a little tuning, like I was talking about. But you know we really bring that core chemistry expertise into this, and that's really the differentiator between what's out there.
And I'll let everyone know we're going to keep going until we don't have questions. So we have a couple more to go. but we're not going to stop in 3 minutes. So if you'd like to keep going along for the ride, feel free. So we'll go on to the next one. Machine learning works best on data that is similar to the training data. When the virtual jars experience anomalies in water quality, how is their accuracy affected? Do they provide a metric such as confidence intervals to indicate its accuracy?
Yeah, so I think there's two parts to that question, I think, that I want to make sure to try and isolate. So the first part is, yeah, we talked about how on a given day or in a given time window, the physical jar test can inform, what that water quality, that treatability. So that's the only historical data that's going into virtual jar and is becoming part of its catalog or guidance. But in the moment, so this is the second part. So the treatment plants, whatever, it could be a calm day, and it's like how is virtual jar working on that calm day? It could be a calm day that it has a different alkalinity combination. It's not looking at the past to help inform what it's going to do that day. It's saying, hey, we're going to measure what the current plant performance is for turbidity removal and for organics removal, and we're going to compare it against what, for the given raw conditions, pH, alkalinity, temperature, the coagulant, the oxidants, all those chemicals that are in there, and what we're forecasting, and whatever that difference is, we will tune or we'll make adjustments. But how we make those adjustments then allows us with confidence to deal with that day and that specific condition. So that we do, again, if you increase the coagulant, you consume more alkalinity. The question is how much and how far does the pH go, which is going to, how much will it increase the efficiency of removal? That's what I mean by that. All those calculations are being done by virtual jars so that we know things will move the right direction and not push things into a zone where you wouldn't want it to go. So.
Thanks, sir. So we've got a version of this question before. So does this mean fewer jobs for operators? Like, how do you answer that? This would be for Brad or Chris. Brad, what do you think?
Well, I know the answer, but I'm going to let Chris answer this one. This is a good one.
That's it. Of course not. Right. So this just allows, again, this is a core function, but it's only one of, 50 functions or whatever an operator has to do, or, 30 functions, they've got lots of things that they have to do. This just really, it does the heavy lifting of these like chemistry calcs, pH changes, alkaline, all that. It also does calculate the cost of treatment. So it brings that, if you add a little more polymer, you do whatever, if you're modifying all the chemicals. So it just takes away some of that heavy lifting. I think the best analogy I've used is we've all probably forgotten what it was like to take out your atlas and figure out how you were going to get from, Chicago to St. Louis, right? That required some energy. You still had to drive. That was the job, drive from Chicago to St. Louis. This just makes it easier and faster to know, hey, here's the paths, here's the thing, and you can make these changes with confidence, quickly, easily, and then go about those other 45 functions that you have to do. So we intentionally do not look for virtual jar to control the chemical dosing intentionally, because the operator ultimately legally responsible for making those decisions. It just helps inform that so they can make those changes with confidence. So our intention is not to build out an autonomous chemical dosing system and take that, again, things we've talked about today, physical observation of the flock, other things that matter and where, the operator can bring that into the mix. This is just meant to be, a superpower, super tool to put in their tool belt to make it so they can do it even better.
Cool. We have another one here. How many years of data do you feel is needed for the virtual jar test to predict accurately? Also, for plants that get a lot of low turbidity water, like below a half a NTU, it can be difficult to determine optimal dosages from a physical jar test because settled turbidity is so close to the raw water turbidity. do virtual jar tests perform well for predicting dosages for low turbidity raw water? So I'm thinking like Colorado right now. It's like
Yeah,
really low.
yeah, exactly. Yeah. Well, or even Brad knows one of the ones that we talked about. Their NTU is about 1 or less, generally even 0.9 NTU, right? So I think this gets back to one of those earlier questions about, do we need a lot of historical data? And the answer to that is no, because it's not calibrating to a bunch of historical data. So um, I think, Chris, that was kind of hinted at. But so then to the, how does it perform with, low turbidity waters? And that part is indeed tough. That's, I think, where the charge neutralization part comes into play. And where I'm going with that is that, what is the TOC? That's why you've got to get that UV 254 or something in there, because that's going to create that additional negative demand. So, are you hitting near neutral? Are you getting where you want to be? Sometimes that's masked by, hey, here's half a part of half NTU, not half a part, but 0.5 NTU. But what's that organics part? So you can make sure you're at least getting charge neutralization. So, the reality is you generally don't need much coagulant, but you want to make sure you're getting the TOC removal. Tends to kind of be almost the focus, even if it's like you said, Chris, high quality water, which Colorado has, that it is that organics part that's moving, that's causing those swings. And so it's good to get that UV 254 get in there, and so you can assess that.
And we're just going to go for a few more minutes here. So we have another one. Would the virtual jar be able to simulate changing to different treatment chemicals, i.e. aluminum sulfate to ferric or various powder activated carbon products?
Yeah, so that's right up our alley on both parts of that. So that's obviously our core business, is helping make sure our customers have the right coagulant, right? And we've got the whole gamut. So it's not like we're just trying to, sell one version of coagulant. And then on the powdered activated carbon part, City of Akron, they leverage their powdered activated carbon as a key part of the TOC removal. And so it's part of the virtual jar. There's a coagulation part, and we actually are now, one of their questions, actually we just met last Friday, is that how can virtual jar easily show them like how much lift can be done by the powder within the allowable dose range they want versus how much the lift can be done with their alum. So, and as the nature of that TOC changes, that answer changes. So the powder can do a pretty good job on some of the lower molecular weight parts of the TOC, and the coagulant does a fantastic job on the higher molecular weight parts.
Awesome. I don't think we've covered this one yet. We have, but not this particular question specifically. When you're running into plants that are saying the jars don't match the plant, is the frustration usually that settled turbidities don't match closely what the plant produces, or that if they try the dose associated with the point of diminishing returns for turbidity, UV 254 or TOC, they don't get good performance?
You want to take first shot, Brad? And then
so I think both. They're saying basically, does the turbidity not match, or does the TOC not match? And we've seen both, right? We've seen. I'll go back to the jar test protocol. If someone settles for 30 minutes in the jar, reality may only be 12 minutes in the plant. So the turbidity is not going to match. We take a lot of time to make sure that the jar test protocol matches the plant. Settling time is a big part of that. So if you don't know how much settling time you have in real life, then the jar test, there'll be a disconnect there. And same on the TOC side. I've seen TOC not match the jars in the plant. Sometimes the mix energy's off. We're not getting enough mixing or contact time in the jars, and then you get into the plant, it gets much better mixing, and TOC removal goes up. So we've seen it both ways, TOC and turbidity.
And I think only thing I'd piggyback on that, Brad, is the main part of what we're extracting from the physical jar test for virtual is that TOC behavior. And the TUC behavior is a little less sensitive to that. And the reason why is because the absorption is fast. So like turbidity really, really matters. I mean, the energy stuff is critical, and where you sample in the jar and where you like, to get, there's a lot of that. Fortunately, the TUC, as long as you're dosing the right dosage, you should be close. Now, if you do see a difference, then it just may be that 2 hours, or whatever the time difference when you sample the raw could just be changed, during that window. I mean, believe it or not, could cause those. So, people always say, hey, our TOC is not changing much, and then you'll still see it move 10 or 15%. So even if it's 3 milligrams per liter, it's only moving between, 3.4, 2.7. It seems like that's not much, but, that can significantly change, obviously, your observed removal. So.
Oh, you got just another one just came in that's really interesting. Can the virtual jar test predict filterability indices between different coagulants, or just the characteristics of what the settled water quality turbidity would be? That is, if you were trying to look for a new coagulant, can the virtual jar test predict which coagulant will perform best or yield the best filtered water turbidity?
Yeah, so we're that's on the roadmap, and that's part of this net zeta piece. And where I'm going with that is that filters, how you backwash them, how you treat them, I mean, all those, how old's the media, right? Like, I mean, there's all these things that I'd say filters are like children, right? You don't know which, I mean, and where I'm going with that is that if we understand the first principles of making sure are we not overcharged to where those particles aren't going to behave as well in the filter process or not. So we're trying to figure out how to navigate that. But ultimately, if you are removing the right TOC, not overdosing your coagulant, depending on what the targets are, those are things that should foundationally then translate to, better filterability performance. So last thing on that, we just added, we have one client, we're still working this out, is that is forecasting unit filter run volume. So obviously, the other challenge with filters is their performance is an aggregate of hours of what's going on then, right? And even if the turbidity moves, the nature of what you're putting on it, turbidity, I mean, the flock wise. So it's an aggregate thing that you're looking at versus, trying to match the treatment of what the water coming in and meeting your target. So we're making progress on that, and but they challenged us to basically do that. Is that, hey, we've got kind of target unit filter run volumes and want to make sure we're matching those. It's in virtual jar, and they're the first ones. They've been operating for about 4 months, so we think we'll have that in there. That's how we're handling it right now. Yep, is going on a unit filter run volume basis.
Really good comment. I'm going to read it real quick, and then we're gonna close. One said, "Sometime the non-match is not due to the jar test protocol, and it is really related to the plant conditions, as how high the solids level is in the sedimentation basin, or some of the filters need to be backwashed, or they're not in good condition." And Juan is actually with Usalco, and that was such a good comment, and it's something that oftentimes we forget is if the solids in the sedimentation basins are too high, that can impact performance quite a bit, and a lot of people tend to forget that when they're looking into optimizing a coagulant or a program. So I want to say we appreciate you all joining us this afternoon. Some of you are longtime customers, some are brand new to Usalco and are just getting to know us. If you would like a specific follow-up or anything, you could drop that into the QA, or you can email webinar@usalco.com. And we also have Chris and Brad's emails listed on that prior slide as well. So feel free to reach out to them, reach out to us at webinar@usalco. We really appreciate y'all joining us this afternoon. Thank you so much. We'll see you all.